So it looks like there's some disagreement with number 3 and number 4. There's some disagreement. Most tables, oh no, you changed. Okay. I think we're okay for number 4. Yes, okay. So we can take that out. We're in agreement that that's incorrect and that this is 16x to the 4th minus 8x squared plus 1. Okay. So this is a tricky one because a lot of times students, when they see this, they want to square each one of these and then they think they're done because you're confusing this with your exponent property that applies to multiplication or division. When you have an adding or subtracting problem in math and you have an exponent, it's very different than when you have a product in there or a division problem. You actually have to write this out using the definition of what it means to square something, and then you have to use your distributive property twice to get this answer. Now, if it was something like this, 4x squared y, and that was all raised to the second power, notice there's a difference between this problem and this problem. This is all multiplication. So there you get to use your exponent property where that 2 will apply itself to each one of these factors. And once you complete that, you're done. However, that big subtraction sign changes life. Subtraction and addition is a whole different ball game than multiplication and division in algebra. And when you get those clarified, it really helps. That's what the problem was here initially, is that you're adding here. And whenever you add in mathematics, things have got to be the same. These are the same. Right here. These are square roots of 2's. So it's just saying, how many of these square roots of 2 do I have? You have 31 of them and 10 of them. Their identity doesn't change. They're not being multiplied. They're not being divided. So you just say, I have 31 of those things called the square root of 2. Okay. Now, if that was the square root of 2 times the square root of 2, then its identity changes. It becomes the square root of 4, which is just 2. So you always have to bear in mind what the operation is, and then that will help you kind of hopefully compartmentalize when do you use different properties. All right, 6, there's always a lot of problems on, and I think I went around and talked about this with everybody, and I see 3/4 everywhere except for over here. And so we will have one similar to this in the class demo in a minute, but this is 1 take away a quarter. And once you see the class demo, you'll understand how we get a quarter for this, which is 3/4. Okay, so let's do the class demo. This one we almost had agreement with, except for when you drop these parentheses, remember that subtraction sign applies to both of the terms in there. So this becomes a +7. So this is negative 1x plus 12. So all but one table had that correct. And 11, I see, disagree. Okay, so here's another big issue. You see this addition sign there? That's one of the issues. The x in the denominator is the denominator for both of those terms. Anytime you have addition and subtraction in the numerator, how did you get this single fraction? You had to combine two things, and this is what they look like. X squared over x plus 5x over x. You can add those together because they're like, just like these radicals were like up here. These are like fractions. Okay, so when you have something that's like, you say, how many of these things with x in the denominator do I have? X squared of them plus 5x. So the problem is people, when they look at this, they have this thing in their head where they remember something with slashes. So they slash that x out with like one of them in the top as it's now written, and they get into lots of trouble. Okay, when you put a slash through something, you're looking for 1, the number 1, which you're allowed to multiply by without changing or divide by. Okay, then it never changes what you have. So you have to rewrite the numerator as a multiplication problem, which we call factor the numerator. So you want to factor x squared plus 5x, which is by what we call pulling out the greatest common factor, which happens to be x. So if you pull an x out of x squared, which says I'm dividing x by x squared, you get an x. And then x times x brings you back to where you are. And then you put a plus 5 here. So once you factor this numerator, you have x times x plus 5. You haven't changed it. You've just rewritten this addition problem as multiplication. That's what the verb factor means. Factor can be a verb or it could be a noun. Then on the bottom you have an x. Now I can rewrite this like this. X over x times x plus 5 over 1. Because when you multiply, you don't need common denominators. And there's your multiplication of 1 right there, which means this is the same as x plus 5. Okay? So before you put a slash through anything, you have to make sure that your whole problem, numerator and denominator, is just multiplication. Then you're free to put slashes wherever you want. Okay? So we're going to go through a little demo now, and then you're going to have about 20-25 minutes to practice together at your seats. I won't make you go up to the boards anymore. So let's take a look at B first, because B caused some people problems in the preview exercises. This is commonly an area where students, when they begin 107, they kind of have a little bit of a meltdown, right? This is rational. This is called a rational exponent. And I think this is in either P2 or P3 in your book. So this is an example of how to evaluate a rational exponent, which means your exponent has a numerator and denominator. And then on top of that, it's a negative rational exponent. So you've got like major issues going on here, right? So again, I was able to explain this to most groups. You have three things going on. You have to deal with that symbol there, that dash that tells you to do something. You have to deal with that 2, which tells you to do something, and you have to deal with that 3. So you should be performing 3 separate actions. If you don't do 3 things, then you've missed a piece of this. The 2 in the numerator always means what it's always meant. It says square something. So square, that means to square something. You could square the 8 if you want, or you could simplify this first and then square it. Okay, doesn't matter the order. The 3 in the denominator, if you think about the denominator, you could think of the denominator as the cellar or the basement. This is just a mnemonic device. And this time of year, when we collect our root vegetables, potatoes, carrots, beets, we put them in the cellar to store them. The roots go in the cellar. That's the denominator. So this says take the cubed root. Again, you can do that first, second, or third. Doesn't matter. This is a positional indicator. This says whatever your answer is, if it's in the numerator, put it in the denominator. If it's in the denominator, put it in the numerator. It changes the position. Right now, 8 is in the numerator. So whatever this simplifies to, you'll put in the denominator. Another way to think about it is reciprocal. So you take the reciprocal or you change the position, whatever's easier for you to remember. So when I do something like this, I always do the root first because it makes the number as small as possible. So I do this first. I then apply my exponent second. And then I change its position by putting it in the denominator, which has a 1 in the numerator. And that's it. So it's 1 over 2 squared, because the cubed root of 8 is 2, which is 1/4. So that's 1/4. Okay. Questions on any part of that, because you will see this for homework. Any questions on any piece of that? Okay, so if we go back to the preview exercises and we look at this one, 32 to the negative 2/5, you take the 5th root of 32, which is also 2, you square it, which is 4, and it becomes 1/4. So 1 take away 1/4 is 3/4. I think there was just one group that didn't get to that. All right, let's take a look at A. What bothers you about A? Is there anything in particular about A that bothers you? Big numbers for the exponents, that usually bugs people. They're used to seeing cubes and squares and 4th and 5th powers. So the big numbers can kind of freak you out a little bit. Anything else? The X and the Y. Yep, okay, you got 2 different variables. And what else do you tend not to like? The fraction, right, and the exponent, right? Because we hate fractions, right? I mean, let's face it. But what is that telling you, that fraction? What is it telling you if we apply what we just talked about, Ray? You're going to take the cube root. That's all it tells you, because the numerator is 1. Okay? The numerator is 1, so there's no squaring, cubing, or whatever. But the denominator, what's in the cellar, is the root. So this says take the cubed root of each one of those factors. Okay? Which, if we apply our exponent property, the exponent applies to each factor here. Each one. Okay? So I'm going to have 64 to the 1/3, which really just says take the cubed root of 64. That's all it says. It looks funky, but that's all it's telling you to do. Then you have x to the 300, and you're going to take the cubed root of that. And then you have y to the 600, and you're going to take the cubed root of that. So if we put this on a new page, because I run out of room because I write so big. Was it 300 first or 600? 300? Okay. Okay. So this says the cubed root of 64. Does anybody happen to know what number that is? 4. Okay. Now this uses an exponent property that is called a power raised to another power. X to the 300 is a power, and then you're raising it to another power. Does anybody remember what you do to the exponents when you have a power raised to a power? You multiply them, right? A times B. So here we have x to the 300 times 1/3, which just says take a third of 300, which is 100. And this one says take a third of 600, which is just 200. And there's your answer. Okay. So this is 2 exponent properties. The first exponent property you're applying has to do with a product raised to a power, and the power is applied to each factor. Notice there's no addition or subtraction here. It's all multiplication. That's the only time that exponent gets to apply to each part in parentheses. There's no addition and subtraction. Then the other property you're using is this property to evaluate these two things. So you're using 2 exponent properties to simplify that. And that's often what you have to do. You often have to use combinations of exponent properties. Again, this is all reviewed for you in the prerequisite chapter. You are all in very different places. You will have a week from Friday to review all this stuff and get the homework done for this stuff. Your first couple of homework assignments are not due until the 11th, to give you time to get used to being in classes again, getting everything set that you need to get set. So you have until a week from Friday to get all of your first 3 classes done, the homework, with no penalty at all. Okay? Any questions on this? Hey, nobody talks to me the first day. I know. All right. Now, what's the problem with C? We've done something like this in the preview exercises. Why can't I subtract it right now? They're not like terms, right? They're not like radicals. They don't look the same. Absolutely, you've got it down. Now, sometimes you can make them look like, and sometimes you can't. You can do a little plastic surgery. You don't change the thing. You just change its appearance. You can make them look like. Sometimes you can't. If you can't, you just say, Linda, I can't do this. It's already simplified. There's nothing further I can do to this. No way, Jose. Whatever you want to tell me. Okay? So the question here is, can we make those radicals look like? And in order to do that, on the side of your paper, you ask yourself, can I factor these radicals into 2 different factors where one of these factors are exactly the same? In other words, is there a radical or a number? Let's make it easy. Is there a number that divides 12 and 27? None. I heard a none. A 3. Did I hear a 9 or a none? A 3 and a 9. 3 and a 9 goes into 27. So square root of 9 times the square root of 3. And if 12 can be written with one of these radicals, you're golden, because then you can make them look like. 12 has a square root of 3. Square root of 12 has a square root of 3 as one of its factors. So we're in luck. We are able to make these things look like. So I rewrite this. I have 3, which is already there, and I change the square root of 12 to be the square root of 4 times the square root of 3. And I have my subtraction sign. There's a 1 in front of that square root of 7. So now you can put the 1 there or not. You have the square root of 9 times the square root of 3. Now you have like terms, you have like radicals, you want to combine them. You can simplify 4 to be 2, so this is 3 times 2 square roots of 3. Take away 3 square roots of 3. This is 6 square roots of 3. Take away 3 square roots of 3, which leaves you with 3 square roots of 3. So you do a little plastic surgery. You haven't changed the meaning of what each term is. You've just made them look like so you can combine them through subtraction. Any questions on that? Okay, and I'm going to go real fast because I want you to have a good 20 minutes to work at your seats. Factor, again, a verb. The first type of factoring that's so critical and everybody forgets about it is finding the greatest common factor in each term and pulling that out front. That's a language we learn. Most people only think about factoring into 2 binomials. So I used to tell my 096 students to cheat by writing GCF on their palm when they have a quiz or a test. That's the only thing I allowed them to cheat on, GCF, because it's so critical to be in the first step of your factoring. So this, to factor this, I pull a 5x out, and I have an x squared minus 9 left. You see how I change subtraction into multiplication. Now, some people stop there, but you have another factoring technique you can use here. X squared is a perfect square, and 9 is a perfect square. And those are the kind of fun to factor because they always look the same. They have the square root of each one of those numbers or quantities, and then you put a plus and a minus, and you're done. That's it. That's completely factored. You can't go any further. Reduce to lowest terms. How do we reduce something to lowest terms? If we have 12/16, we factor it until we find a common factor, and then we divide that by 1 because you have a 4 over 4, and we call 12/16 and 3/4 the same exact quantity. Again, factor. Everything has to be factored to do that slash. So this factors to be x plus 5, x minus 2. And this is what I say to myself. I'm searching for factors of 10 that differ by 3. Right away, 5 and 2 come to my mind when I use that language. I put a 5 and a 2. I know when I add the middle term and the outer term, I get a plus 3. So my plus goes in front of the 5, and my minus sign goes in front of the 2. Similarly, with the bottom, factors of 8 that differ by 2 are the 4 and 2 combination. So I don't worry about the sign. I put the 4 and the 2 in. And then I say, okay, what will have the plus and what will have the minus? Since I end up with a plus 2, I put the plus in front of the 4 and the minus there. Now it's factored, and now I search for that 1. I'm going to divide by 1, so I reduce it, and here's my final answer. X plus 5 over x plus 4. Now notice I put those in parentheses because this way I see that they're very different animals. If I drop the parentheses, there's this evil temptation that lurks up into your hand and wants to cross out those x's, which you can't do, because if you drop these parentheses, it then becomes addition. And you can't cancel terms, you can only cancel factors. So use parentheses, be like redundant with parentheses sometimes. Just use them wherever you can when you're factoring and reducing. So you now have almost 20 minutes to work on your class activities. And what I would suggest, and this is really up to you, you can work by yourself with your group, you can work on the boards, use it, but look them over and go to what you think you're going to have the most difficulty with while you still have resources available to you, like your classmates or me. Okay, so I would suggest leaving the things that you absolutely know how to do and work on the problems where you may need some assistance. Okay, I'll put the music back on and